Okay, let's talk about reference triangles. Reference triangles are your friends. So, say for example, somebody asked me to find the sine of 150 degrees. I absolutely could go through the trouble of drawing a unit circle, looking at my unit circle, and finding it. So, our directions here would probably say find this exactly, which typically means don't use a calculator. Find it exactly. I don't want to draw a unit circle for one question. So 150 degrees is over here in quadrant 2. There's 150 degrees. What I'm going to do is draw this reference triangle that lives against the x-axis, the horizontal axis here. Notice my right triangle lives right here. The right angle is right against the x-axis. Then my reference angle, if this is 150, think about how big this angle has to be. Well, all of this would be 180. So this must be a 30-degree angle, 180 minus 150. So let me draw in just the reference triangle here. 30 degrees. Now I know I have the 30, 60, 90 triangle memorized. I know that there are two different ways I could draw this triangle in. I could go 1 to root 3, or if I like unit circle answers, if I want my hypotenuse to be 1, then this side here is 1/2 across the 30, from the 30 is a half, and the other side is root 3 over 2. That's just a 30, 60, 90 triangle. Here comes the kicker now. I have to look at my picture and put in the pluses and minuses. By just looking and seeing, did I go left, right, up, or down? Remember, hypotenuse is always positive. Look at this horizontal distance I went here. So I start at the origin. I'm trying to get to this point. That's really what I'm doing. I went left. That's a negative. I went backwards. I went up. That vertical is a positive. Same thing on this one. These are really the same triangle. That's a negative x value, if you like, and a positive y. Then, to find sine of 150, I just do opposite over hypotenuse using this reference angle. Opposite over hypotenuse. Sine of 150 degrees is positive 1/2. What about cosine of 150? Well, I've already got my triangle here from this reference angle. Adjacent over hypotenuse. Negative root 3 over 2. I can also, by the way, and should keep in mind, all students take calculus. I'm in quadrant 2. In quadrant 2, sine is positive, cosine and tangent are both negative. Remember, the letters tell you who's positive in that quadrant of the big three of sine, cosine, and tangent. All three are positive. Only sine, only tangent, only cosine. So without doing much work, I know cosine of 150 is going to be a negative. I'm in quadrant 2, and tangent is negative in quadrant 2. And now I can just use my triangle and go opposite over adjacent, or this one, either one, opposite over adjacent. This one doesn't have fractions in it, so I'll use that. 1 over negative root 3, that we would probably write as negative 1 over root 3. Or if you like to rationalize denominators, we could multiply top and bottom here by root 3 and get negative root 3 over 3. Okay, let's do another one, another unit circle one. Maybe we want to find cosine of oh, let's say 225 degrees. So that's bigger than 180, but less than 270. That is over here somewhere. So there is 225 degrees. I'm in quadrant 3. Remember, it's quadrant 1, 2, 3, 4. I know all students take calculus. So I know only of the big 3, sine, cosine, and tangent, only tangent is positive. I know my answer is going to be a negative. Let's figure out what our little reference angle is here. So this would be 180. How much further did I go to get to 225? 225 minus 180 is 45 degrees. So my reference angle here is a 45 degree angle. Hey, I know the 45, 45, 90 triangle. I know it goes 1, 1, root 2. Or if you like, if you want your hypotenuse to be 1, these are both root 2 over 2. Now I have to put in the pluses and minuses myself. That's where people make mistakes. You got to put in the pluses and minuses by looking at the picture. Look at this horizontal right there. That's a -1. I've gone backwards. And then down. So think you're literally walking to this corner, this point. You got to go backwards and down. Both of those are negative. Hypotenuse is always positive. Then cosine of 225 degrees is just like cosine of 45, only it might be negative. We just use our reference angle. Use that 45. And I could use either triangle. I'll use this one over here. Cosine will be adjacent of the 45, adjacent over hypotenuse. Negative root 2 over 2. Okay, so those were unit circle questions. Any of those, we could have just drawn the unit circle and gone. What if we have something that's not on the unit circle? What if, for example, I'm told, suppose sine of x is 5 over 12 and cosine of x is negative. Find, let's do a bunch. Let's say tangent of x, secant of x, cosecant of x, and the cotangent of x. Now, this is not a unit circle question, and it's not a calculator problem. So I could say find the following exactly. If you see the word exactly, you're not even going to be getting your calculator out. Okay, well, we draw our reference triangle. We got to figure out what quadrant we're in. First, sine is positive because 5/12 is a positive number. Cosine is negative. Where is sine positive but cosine negative? There's only one quadrant where that happens. That's quadrant 2. We are in quadrant 2. Remember, all students take calculus. The only place where sine is positive and cosine's negative is quadrant 2. Okay, so I draw my reference triangle. Here's my little reference angle. This is the angle x, but who cares? I'm looking at this triangle. Sine is opposite over hypotenuse. So from this reference angle, opposite must be 5. Hypotenuse must be 12. How am I going to find that third side? I'm going to have to use Pythagorean. So maybe we'll call this side A here. Then a squared plus 5 squared should be 12 squared. A squared plus 25 should be 144. A then would be A squared would be 144 minus 25. Let's we might use our calculator to do some arithmetic, but we're not going to do the whole thing. We get 119. So A squared is 119. A then is plus or minus the square root of 119. I have to look at the picture and figure out whether I want the plus or the minus. Look at this side here. That's a negative. I've gone backwards. Over here, these would be positive horizontals, negative. This is negative root 119. Now, from this triangle, I can literally just read off all of these. Tangent will be opposite over adjacent. 5 over negative square root 119. Secant is just 1 over cosine. That's the way I think of it. So I would look here and find the cosine first. Cosine would be adjacent over hypotenuse. I got to flip that over. Hypotenuse over adjacent. 12 over negative root 119. And if you handed these to me, I don't like having a negative in the bottom, so I would write both of these as just negative fractions, but it's fine. If you want to leave the negative in the bottom, there's nothing wrong with it. I would just write it as a negative fraction. Remember, you can in a fraction, you can put the negative on the bottom, on the top, or just out front. Okay. Cosecant. Cosecant is just 1 over sine. It's just sine flipped over. I don't have to do any math. Just take sine and flip it over. 12 over 5. I'm done. Cotangent. It's just tangent flipped over. I'm just going to take tangent there and flip him over. Negative 119 over 5. Okay, and that's a good place to stop.